Hello everyone and welcome to this video. Today I'm going to be giving you an entire behind the scenes of how I created a LayerLUT exporter for After Effects, a feature that has not existed at all in the history of After Effects, but finally I've added it so that you have a layer, export LUT option. You can export a LUT in just a few seconds out of all the effects applied to any given layer. The first link in the description will be to the product itself where you can check it out, buy it to support me, or just have an awesome LayerLUT exporter. But today I'm going to be going into depth on the history of this plugin, what it took to create it, the problems I had along the way, and that will give you an idea of not only the challenges that you might face creating your own products, but it'll also give you some inspiration and insight into the whole process. So if you're not already familiar, this is the second probably video I've made on the subject. The LayerLUT exporter will take any effects you have applied. So in this case, I have a curves and a hue and saturation effect applied. And if I select my layer and go to Layer, Export LUT, I can say like save it here on my desktop and just call this tutorial blue because it's mostly a blue tint that we're applying in this case. It'll export just like that, and you can see we have it now on our desktop. In this case, to be technical, the LUTs are 64 by 64 by 64. This creates a cube file of about 7 megabytes. This is actually pretty much all the accuracy you need for anything that's like 4K HDR and below. If you do need higher quality, we can actually probably make a bigger version to support 128 size LUTs, but I haven't seen a use case yet, so if you do, let me know. But to make sure that it works properly, of course, you need to reapply the LUT to your layer. So if we type in apply, we can apply a color LUT, select our tutorial blue, and just like that, have our effect recreated completely perfectly. Now, this has been a long time coming, and there's a lot to go over, so let's go ahead and get started with the whole process, a little bit about how it works without spilling too many secrets, and more. So I've teased this cube before in a couple of tutorials. I can't remember how long ago it was, but this project has been in the process for a little bit over 2 years at least. The idea has probably been a little bit longer, but the actual attempt to program a LUT exporter has been about 2 years in the making. And I spent most of the time trying to figure out how to visualize what a LUT or a cube file is. The reason they're called a cube file is because it can be represented as a three-dimensional cube. And on the cube itself, with any three-dimensional object, you have three axes, the X, the Y, and the Z. Now in this case, instead of X, Y, and Z, they're actually going to be represented by R, G, and B, or red, green, and blue. And as you start off on your cube at the very origin point, when you haven't gone along any of the axes, you start with a black. And as you go on the red side, you get more red. As you go on the green side, you get more green, blue side, more blue. And as you combine them, you get colors like yellow, magenta, cyan. And when you combine all three channels together, you get white. So the first step in this whole process, after I came up with the idea to have a LUT exporter, is to sort of understand how to visualize what a LUT is. And I do that by making these little cubes, which sat around and I would just stare at for a long time thinking, okay, I think I kind of understand it. And I think it would have probably benefited me more if I did some kind of 3D model. As you can see, I'm probably using some visuals in this video to help show you a little bit easier. I created these after the fact, but the fact is that when you have a cube, you have three axes with three different colored channels, and as they increase, they start to blend together. And basically, this is representative of a standard color space. The other thing to understand about a cube is it does have dimension. Each axis doesn't go on forever into infinity. You need to define how big the cube is. And the bigger it is, the more colors it can hold. So in theory, if you have a ginormous cube file with lots of data inside of it, you can store more information and more color correction sort of data. In most cases that I've ever seen in looking at different cube files, I've seen 32 and 64 sized cubes. That means each axis, the red side has 32 or 64 intervals, the green side has 64 intervals, and the green side has 64 intervals. And each interval will add all the way up to 1.0. So each channel is at 0.0 and goes up to 1.0. we use a floating point number, which gives us more decimal places and detail essentially than just using 1, 2, 3, 4, 5 all the way up. Okay, so that's the basics of how the cube itself works. You have three axes, you define how big the axes are. The bigger, the more information it's going to store, and it represents a color space, in this case, a standard color space. So where do we go from there? Well, for me, it was to start developing the plugin and kind of figure it out as I went. Of course, the first step was to decide, how am I going to make this tool? Is it going to be a effect plugin, a general plugin, a script, a combination? In this case, it's about 95%, maybe 99% After Effects general plugin. There's a little bit of scripting just to add a pop-up UI that says, hey, we're exporting, it's going to freeze, just wait a second. But the rest of everything is done with entirely AEGP. So I decided the layer menu is probably the best place for it because you're selecting a layer and you're selecting and exporting a LUT directly from that layer. So the layer menu makes the most sense. Okay, we got the basic dummy plugin set up. It's in the layer menu. It's going to export a LUT. How do we export a LUT? This is the part that really took me years to figure out. Of course, there was some break time in between failures, but it took about 2, 3, or 4 different times of rewriting all of the code and trying to find an algorithm or a method that would create a LUT. First, what's the concept of creating a LUT? How do we do such a thing? If we look at the actual LUT file we just created, let's quickly take a look at what's going on inside. First, I just have some comments that say, hey, this was generated by me with my tool LayerLUT exporter. For more, check out my YouTube and my aescripts. Here's the actual title of the LUT, which is based on the selected layer name. And then the LUT size as well is important to include. But then the main meat is all of these LUT data points. Now, in the case of a 64 by 64 by 64 LUT, or 64 cubed, you're dealing with 262 144,000 data points. Because if you take 64, multiply it by 64, and multiply it by 64 again, that's equal to each of the RGB axes, you get this many data points. So this is how many colors we're essentially storing in a LUT file. And each of those color points has an RG and a B value. What this practically means is that for every one of these 262,144 points, there is a color associated with it. The very first one is black, and the very last one is pure white. Now, and everything in between is just a slice or a part along the sort of cycle of each axis. So the trickiest part about LUTs and understanding the file itself is how the data is represented. You're basically crushing down this three-dimensional color space into one dimension. And that one dimension is the column number of your LUT. So starting at, this is actually 0 because we have some other information above it, but this is 0. This is pure black, a unique pixel. The next one is another unique pixel with just a little bit more red added to it. And the next one after that is the same one as previous, but with a little more red. And it goes all the way down and does some cycles to eventually get to pure white. But essentially, what you're doing is representing each one of these rows here as a unique pixel color in a color space, which in total we get 262, 144,000 total unique colors represented, which in most cases is more than enough to fully represent a color space in any resolution and HDR even. Now, with more of that rambling, how does one create a LUT? Well, what are these RG and B values for each unique row pixel representing? Essentially, these are the values to set that to. So here we have the very first data point. Let's say it's pure black. It means that along our color cube, we haven't added any information or any value to the red, green, or blue channels. We're at pure black. That's what the input pixel is. But what these RGB values for this given pixel represent is the output. So this here, let's say, is black. If I change, say, the red channel to 1, that's going to say if we encounter a pure black pixel, the red value needs to be cranked all the way up to 1. These other two values here can stay the same. So what it's basically saying is, no matter what, change the value of a pixel to these RGB values. If this is pure black and we set it to 1, 1, 1, that's going to say set pure black to pure white. Likewise, if we go to the very bottom, which is going to be representative of a pure white pixel, we could maybe say set that to 0, 0.0, 0, 0.2, and we could even do something like 1.5 and have HDR over brights. And that's going to say when we encounter a pure white pixel as the input, when we apply this LUT, these are the actual values it needs to set them to. So what all a LUT is a bunch of pre-computed data telling you what the input is and what the output is. So for all of these 262,000 colors, we've pre-calculated some values of what they should be on the output. Basically, it's telling you every pixel it looks at of your image has a predefined change that it's going to be set to. And that's all the LUT is. It's a pre-calculated value for each of the unique pixels. So awesome. We know how to get sort of the 262,144 unique pixel rows. We really just have to count that number to get that many pixels. But how do we decide what the output value is supposed to be? Well, with After Effects general plugins, we have the ability to read an image and check the value of every pixel of an image. So my very first idea was that, okay, this is super easy. All we need to do to create a LUT is turn off all of our effects, analyze all of the pixels inside of our image. We're just going to go row by row. We're going to analyze every single pixel, and we're going to say, okay, we have these certain pixels. Maybe we don't have enough to color the whole spectrum. For example, if I have an effect that makes our image super dark, we're missing a lot of information in this picture. We're missing a lot of bright colors, we're missing a lot. So if we were to analyze this entire image, we're only going to get maybe 5 to 10% of the full image that we need, or all the data that we need. And that was kind of, as you'll see, my first issue with my first method. But again, we're going to go through, like this is what I was doing at the time of developing the first version. We're going to go through each pixel. When we find one, we're going to say, okay, cool. We have this pixel. That means we can analyze after the effects are applied what it should look like. So let's say, for example, we choose one of these pixels here, right? Like, okay, we got this pixel. Remember that. Now, apply our effects. Now we have a new value. Let's say in this case, let's say like one of these pixels here becomes much more blue, as you can see. So before, let's say it was a pure gray pixel, right? Dead center of our cube, pure gray, somewhere inside of there. The output is going to be something more blue. To show you practically, let's say we pick this pixel here, right? This pixel here has the following values. Again, this represents a unique location in our LUT file. This is a little bit brighter than gray, but okay, so we have 0.65, 0.69, 0.66. We analyze that, we apply our effects on top of it, and now when we analyze it, look, we've actually reduced the red value, increased the green, and greatly increased the blue. That means we have these values here. These are what we're going to write in our LUT file for that row. Let's say this was the black pixel and all of a sudden it's like that. Then we would basically go into our LUT and we would say, okay, this one was like 0.5. This one was like 0.7. And then the blue was like 0.8. And boom, we do that for each of the pixels we find and we know what their output is. That way, when we reapply this LUT file, it's going to recreate the effect. It looks at the image before the effects and then after the effects are applied for each pixel, and then it applies basically what the color correction is. Simple. Well, actually, not that simple. Why is it not that simple? Well, as I mentioned, if we have a bunch of effects applied that change the image drastically, let's say this, we've darkened it, and let's say we tint it very red. Okay, we have a color correction effect. But when we analyze these pixels, let's make it even more extreme. Think about how much variation we have in this image. We basically have some dark blue and red, maybe some pixels in between. But do you think there's 262,144 unique pixels in this image? I'd say probably less than a couple thousand. So if we need a full color cube worth of color, but we just have a tiny portion of this, we're going to have a problem. And that problem is when we apply this information to any other clip, it's missing data. For one, this input image has not very much green or red. So if we apply it to an image that has green or red, the results are not going to be the same. And again, we have a tiny portion of the entire required color spectrum to create a LUT. So my second idea was once I had this information, maybe I have 10% of the entire LUT file created. It's not a lot to deal with, but hey, we can use math and do some interpolation. We can do averages. We can find the minimum and maximum of the red channel, the minimum and maximum of the green channel, the minimum and maximum of the blue channel, and then average between them to fill in the cube. This worked for a couple cases, but by no means did it work for all of the cases because some of the images would have a lot of information in them, other ones would have no information. For example, if you had a picture of a night sky with stars in it, you have like 2, 3 colors in that. Some images I tested would have a lot more data and give me false results, being like, yes, I figured out the algorithm, but then when I applied it to another type of footage, it would not work. So, big problem with method number 1 and iteration number 2 was that if you have an input image missing a lot of color information, the output is also going to be missing a lot of color information and changes. Even if we have 90% of the information, it's still not enough to cover when you apply it to a different piece of footage or a different clip. So after that, I really spent a good another 6 months or so taking a break and then coming back to the already established algorithm here. And I tried every kind of interpolation. I tried trilinear, I tried hexadecimal interpolation to try and see if with limited data, I could recreate a full LUT. And after, at that point, almost a year of experimentation and failure with some false positives saying, oh, that's a good looking LUT applied to something else, it looks terrible. I had to figure out a completely new solution. But the problem is, if my input image looks like this, how on earth am I gonna get the blues and the greens that required and the whites and the dark spots? It's almost just pure red. How am I gonna get these values to recreate into a LUT file and then apply perfectly into another file? The answer took another 3 or so months, and this here is the answer. I mean, it's not the only answer, but it is the idea of the answer. This here is a 512 by 512 image. How many pixels is 512 by 512? It is the amount we need as 262,144. Do you see where this is going? What does this look like? It looks like a really bad PowerPoint background or something like that. But what this really is what I like to call a constant noise reference. Essentially, this contains every single unique pixel we need. Remember, our problem is that when we have information like this, we're missing like 90% of the pixels that we need to analyze the before and after effects of in order to get an accurate LUT created. But with my noise reference, I have all of these possible pixels that we need to create a LUT, one for one. We can go through this image line by line, pixel by pixel, and it's going to give us every single input value that we need. So basically what this is it has all 262,144 possible pixels in our LUT file, and all we have to do is loop through it. We go through line by line, pixel by pixel, and we analyze each pixel. But actually, it's better than that. We don't even have to analyze this until we apply effects to it. That's right. That's the secret. You gotta use something like this, which has the colors already built in, and all we do is copy and paste the effects onto this. Then all we have to do is analyze each of these pixels, and we know what the output's supposed to look like. So maybe we apply the effects and one of these pixels changes. That's the way it needs to change. It's simple. Because the issue was that our effects were being applied to footage which did not always have the full color spectrum in it. So what we do is apply the effects to something with the full color spectrum in it. Because with that, we can analyze the effects before and after and not have to do any interpolation, nothing. All we have to do is analyze the output values of each of the pixels, and boom, that is our LUT. That, of course, is oversimplifying some steps. There's a lot of code that was required, about 1,000 lines total in this AGP of just functionality. There was no interpolation needed though, because we have all of the pixels represented, but there were some cycling and looping and things like that that had to be worked out to make sure that not only would these LUTs work in After Effects, but also Premiere, Resolve, or anything else that uses LUTs. So it had to be tested a lot to make sure things were going to be universal. But that was the solution that ended up coming about after about 2 years of experimentation, frustration, failed methods, and learning all about cube files and LayerLUTs. So I hope you guys enjoyed this deep dive. Hopefully I didn't give away too much sauce, secrets, and all that stuff. But if you enjoyed, make sure you leave a thumbs up. Make sure you check out the product in the description down below. This thing is awesome. I kind of actually want to export this LUT here and just call it like super red. The whole point of making sure we did the method the way it does is so that when we reapply it to that or any other footage, it's going to look super nice. And then when we apply it to something completely different, we're going to get the same exact color recreation as well. But yeah, check it out, support me. Export LayerLUTs super fast on both Mac and Windows for After Effects. Thank you guys for watching this video. We'll see you next time.